Let's take a closer look at the energy modeling in Grasshopper using the same shoebox model. From the previous video, we learned that if we make the unit system consistent for Rhino document settings, Rhino geometries, and Grasshopper geometries, we can ignore the unit conversion. The Grasshopper geometries were modeled in meters in this template, so I'll double check my Rhino document unit, which is in meters now. I don't have any geometries in Rhino for this example. To make the energy model simpler, let's bypass all the scaling factors. Now, delete the unit conversion and the scale batteries. Then hide the model maker battery and look at the elements one at a time. Show the zone geometry, which is a closed box. This energy zone battery takes one or more closed B-wraps and creates thermal zones. If you click on the settings, you can set the zone properties such as loads, heating cooling set points, and envelope construction. We went through these rather extensively in the previous videos. The next battery sets the HVAC system for the zones. In this example, we're using the ideal air load system. Click on the settings. You can change the COP, operation schedules, set points, etc. You can use a different HVAC system if you want, for example, a VRF system. Once the zone and the HVAC systems are set up, we can connect it to the systems input of the model maker component. The next element is windows. The geometry is the entire north facade of the zone. This cluster here creates a smaller B-wrap based on the window to wall ratio, in this case 80%. If you double-click on the cluster, you can see the detailed definition that comprises the cluster. Let's exit the cluster and go back to the main definition. The window battery creates windows based on the input B-wraps. You can click on the setting button and change the glazing, shading, and ventilation schemes. Once the windows is set up, we can connect it to the window input of the model maker battery. If the thermal zone is on the ground, you can model the bottom surface as the ground using the boundary condition battery. You can toggle between adiabatic and ground. In this case, we can set the bottom surface as the ground if you want. We can connect the ground to the boundary condition input of the model maker component. You can also model the adiabatic surfaces with the same logic. Just to remember to set the toggle to adiabatic and hold Shift key to add it to the existing boundary conditions. In this model, we have a B-wrap for shading, which can be directly connected to the shading input of the model maker component. Once the energy model is all assembled, we can feed it to the Energy Plus to run the energy simulation. On the Run Energy Plus battery, make sure that you choose the correct weather data for the project location. If the drop-down box does not contain the site location, you can add the site from your Rhino interface. Once you add the EPW file to the system, you should have it in the drop-down box. The emissions battery shows the emission factors. You can click on the settings and double-click on the values to change the emission factors if you know the details for your project site. If you click on the settings, you can set the simulation period, temporal resolution, and output variables. Once you have the thermal model configured, you can click on the button to run the simulation. For the visualization panels, there are often input variables to tune the graphs, such as the size of the chart or the text. There is also a mode input to choose which metric you would like to show. In this case, 0 is EUI, 1 is the total energy used, 2 is the energy balance, etc. You can use a number slider to control which metric to visualize. This is how Climate Studio energy simulation is set up in Grasshopper. In the next video, we will model a 3-story building and run the energy simulation.